Kia ora. Welcome to Women in Data Science, Auckland 2020. This year, we have a series of talks from women sharing their stories about their work and career contributions across many industries. WAVSL Auckland is an independent event organised by the University of Auckland Faculty of Engineering to coincide with the annual Global Women in Data Science Conference. I'm Kate College, WAVSL Ambassador, and I'm delighted to be here to help share these inspiring stories. Today's speaker is Galina Mitchelhill. She is a Senior Manager of Research and Analytics at New Zealand Transport Authority, where she leads a team of data scientists, geospatial analysts, as well as market and transport researchers. Galina is also the chair of the Research Association of New Zealand. In today's talk, Galina shares some of the innovation that her team at NZTA has been working on.
Hey everyone, I'm Galina Mitchelhill and I work for Waka Kotahi, which is the transport agency in New Zealand. What I'd like to share with you today is a little bit about the work program that we're actually doing at the agency and specifically in the data science space. So to get started, I'm not sure how much you know about the agency itself. So just in case you aren't quite sure of what we actually do, there's a couple of functions that we're specifically responsible for as part of government. So the first one is around the administration of the state highways. So that's around the building and the maintenance of the state highways, which I'm sure you all have driven on across the different years. The other thing is also the regulatory, which is around safety in driving and also in the vehicle licensing space. So what I'm going to do now is just show you where the data science team fits in relation to the rest of the agency and also in relation to the wider research and analytics. So I actually look after the wider research and analytics team, and what you can see on screen now is the different components of that team. So one of the things which we're really lucky for at the agency is to be able to have quite an eclectic team of people who focus on insight work, be it from an analytical point of view or a research point of view. Which you can see there. And the whole purpose of this team basically is to provide really good insights and really good evidence for decision makers for all the different types of decisions that they make. And also sometimes it's the wider sector and even sometimes it's for the general public as well. So you can see there that the advanced, what we call advanced analytics and modelling team, which is the data science team, sits within the specialist analytics group. They sit alongside the geospatial team and also what we call our descriptive and diagnostic analysis team called data services, who do a lot of the mining of our registers. In terms of the data science team itself, the team is focused very much, as you can imagine, as data scientists on the scientific methods, the processes, the algorithms. There's 7 of them in total. And we're very lucky at the moment where across the all of government program, the GovTech program, we've actually got 2 grad data scientists with us as well. One of the real strengths of the team is that they've got a real diverse background in everything from AI to transport engineering through to robotics, through to mathematics, civil engineering. It really is quite a range, and that range really puts them in good stead when they're working across the range of projects that they actually do. So what I'd like to share now is some of our core work streams at the agency in the data science space. So there's 4 core work streams which we focus on here. The first one being network performance, which I'll talk about a little bit more today. Also safety, which I'll also talk about. And there's 2 other streams, the environment and regulatory, which I won't talk about today, but certainly if you're interested and you want to know more, then always do feel free to give me an email or send me a LinkedIn message or something. Right, so in terms of network performance, where the focus really here has been on, first of all, making sure we can monitor the network, as well as getting close to real-time analytics as possible, plus also doing predictive work. So you might think, well, what might be this type of questions? We might be interested in network performance. When we mean network performance, of course, what we're talking about there is our highways. So, you know, the typical sorts of questions which are really important to us are ones like, you know, are the journeys for our customers, you know, the people who are actually using the roads, actually getting better or not? Or are they worse? And so I've got a few things to show you later on that. You know, when's the best and worst times to actually get on the road when I'm actually going on holiday? What will actually happen if I close a lane of motorway? I'm sure you've all been in that experience where you go, did they actually understand what was going to happen when they closed this lane, or did anyone think about that? So that's the sort of work our data scientists have started to focus on. Also, if something happens, even if it's planned, you know, say we decide to shut 4 lanes of the Harbour Bridge, for argument's sake, in Auckland, you know, what's actually the cost of that economically? You know, what freight is not going to get across, or how much slower is something going to happen? What's the cost of those unplanned or planned incidents? Also congestion, you know, do we know that it's better or worse? Do we know what actually averages? And do we know what we should be telling people to expect? And another interesting one, another question that gets asked of us is, well, where do international tourists go? And I know you're going to say, well, we don't have any at the moment, and you're right, well, we probably do have a few, but not many. But when the international tourists are here, they make a huge difference in terms of what happens on our roads. So being able to understand what happens with international tourists, where they go, how they flow across the country, what are the key routes, it's actually really important from a maintenance or a congestion, and also from a safety point of view as well. So that first question which I talked about, which is around customer journeys and are they getting better or worse on our roads or not, is actually one area which the data science team has actually had quite a lot of focus on over the last 6-12 months. One of the things that we were really keen to do was to improve our ability to be able to really get a full national view and a consistent view of how this network is actually performing right across the different types of state highways. You know, because you have urban highways, you have rural highways, you have local roads that also make up the highways, or on and off ramps around highways. And all these things, that it's really important for us to be able to know where we should be putting our effort in terms of the expenditure that we've got right across the country. And to be able to do this, this involves heaps of data. And I tell you, this is a lot of data. You can ask the team about it. For instance, 6 billion customer trip legs every year. Now that's quite a bit if you think about it. We've been pulling the data down, and I've actually got a slide on where we get the data from for this next. But it took ages to get all this data into a format that we could use it when you think about we wanted to go back across years as well. What's really important in this is that we're actually pulling data where it's actually coming off customers' actual behaviours or road users' actual behaviours, because that's really important in terms of really making decisions where we're actually being quite customer focused about it at the same time. So there's over 10,000 kilometres of routes in that, and it's really looking about how predictable and how punctual, how free-flowing versus congested the traffic actually is over those periods. TomTom is the data that we use. So we've been ingesting TomTom data, we've been standing it up as a proof of concept, and we're just in the process of actually putting it permanently into our data warehouse now and setting up regular pulls of the data to update. Now we've actually got the big backlog of data that we needed to be able to do the baseline for this modelling. It's very, very detailed, the data that we get. It's got a lot of information around the routes and the segment level data with the travel times, their speeds, how many people are actually included in that sample that they give us. It's time-stamped, it's geocoded. So you can see it's very complex data and quite a lot of data that we get and that we're actually using. So once the data scientists have been working with the data and we've actually got it to a point where we're actually starting to get the insights out, we want to be able to get it to a point that we can actually productionize the data. So we can actually serve up the insights in a way that's really easy for our end users at both a high-end managerial level, but also out in our operating centres around the country to be able to look at what's actually happening on the network. So one of the things we've done is that as the data scientists have moved from ingesting the data, working with the data, pulling out the insights, we're now serving this up in a click dashboard as well. And what you're seeing on screen at the moment is a high-level view. This is just draft at the moment, so don't read anything into the numbers. They're just there in terms of what we've put in for the time being as we're actually building this dashboard out. But as you can see, at a glance, you could start to look at it from a traffic light point of view in terms of what's working, what's not, how things have changed from a year ago, and also look at it in terms of how different areas are performing relative to others. You can also drill down, so you can look at it by different regions. So you could be very specific, you could look at it by month, and you could look at it by peak times as well. We've also got a geospatial overlay in here as well. So this is mapping a specific journey, or I guess you say road area, and having a look across it. And you can, again, like I said, drill down at specific times or days, etc., to go, what does that journey look like at that particular time? So this helps us to really understand what's actually going on right across our networks, to be able to go, well, where is it that we need to put our focus on? Where can we see that we've got some systemic issues going on, and look at it from a holistic point of view, as well as doing it on a day-to-day, hour-to-hour point of view of what's actually happening in the network. Okay, slightly different, but hopefully this is something which is dear to your heart, is when you go on holiday, you want to go, oh, what time should I leave? Shall I leave early? Shall I wait until after the morning rush to be able to go on that 3-day weekend that I want to be able to take? So we called this holiday hotspots previously, where what the data scientists are doing is they're providing advice and doing some prediction work on what's actually going to happen to the traffic on public holidays. So, you know, what are the times when it's going to be quite disruptive to travel, and also provide that in advance. So you can go, oh, but Google does that. It's like, well, okay, Google does do that to some extent if you're actually in the traffic. But wouldn't it be nice to know before you got in the traffic what the traffic was going to be like 2 days in advance? And so this is what this is about. So some of you might have seen, for instance, the holiday hotspots in the media. And this is some examples from December, our last Christmas holidays, where our holiday hotspots and the work that we've been doing in this space, predicting when the traffic's going to flow and when it's not, was released out and was picked up across the country. So hopefully some of you might have used this and you would have the chance not to get stuck in the traffic quite so badly. I know some of you, if you're here in person, would ask the question, well, how are you going to predict this now, given the fact that everything's so different? It's a good question. Right, if you remember, the second thing that I had there was road safety in terms of the 4 work programs. So here in the road safety space, there's a whole gamut of stuff that we're doing, which is wider than analytics, it's research as well, but specifically in the data science space, there's a lot around risk modelling, as well as general analysis, and also looking at performance indicators. You know, the types of questions which are dear to the heart of the safety people will be things like, you know, how much effect does installation of safety cameras on a highway have on driver behaviour? Good question. And crashes. You know, how much impact, you know, if we're going to put in, should we be putting in variable speed limits, which are weather activated in certain places, to see what impact they might have on reducing crashes on a certain highway? Yeah, is there overrepresentation in our deaths and serious injury crashes in New Zealand by certain ethnicities or communities? So you can see there's a whole range of questions that sort of pop up in the safety space. And all these questions that I've been mentioning are questions which our data scientists have been working on and working with the organisation on, and sometimes the wider sector on as well. One of the ones which I'm going to show you in a minute is what are the best materials to use for building safer and low maintenance highways. Really, really important, because we want to make sure that we make the most of our money and use it well, but we also want to make sure that it's best from an environmental and also from a safety point of view too. So one of the examples I just mentioned before was the weather activated speed limits. So for instance, if we know that the weather is going to be bad in a particular area, there could be an advantage in reducing the speed limit for that period of time, for instance. So what the data scientists are doing in this space are looking at the crash data for different areas, and I know they've specifically done it for 2 sites recently, where they look at, well, what's actually going on in this space? You know, what is the history of crashes? Could they have been mitigated by having in these speed limits in place? You know, what can we learn about the crashes themselves, the conditions that were actually happening at the time? Where would be the best place to actually put these speed limits if we were actually to put them, and where should we actually start and finish such speed limits? What's the right place for that? And how are we going to evaluate them? So what does success look like? What would we expect, and how effective would we actually expect them to be? So using a whole lot of different data sources, from the roads themselves, from the speeds, from the TomTom data I talked about, from the vehicles, from the crash analysis information that we've got too. The data scientists have been working with our teams to figure out just what impact and where it makes most sense to put those. I mentioned before the longevity of highways in terms of, well, when we're actually going to actually repair or put down bitumen in some of our highways, how do we know that we're actually using the right type and what actually affects it? So the data scientists have got involved in here in terms of using machine learning with survival analysis to actually assess how well that renewal program delivery has actually been working, to make sure that we're actually getting the best bang for buck at the end of the day, and we're actually getting the best outcomes as well. So this is quite an interesting one. Again, we've done a project in the last year of this, and it's very much part of what we're starting to build up is our repertoire of looking at how we can use data science to make sure that we're evaluating, as well as being at the front end, but also being at the back end in terms of evaluating what success looks like, what can we learn from that, and how can we actually push that into the decisions that we need to make for our investment programs in the future. Now, I couldn't do a presentation without mentioning COVID-19. I know you thought you were going to get away with it, that I was not going to mention it, but here it is, I have. Obviously, when we went into lockdown, the big question on a number of people's lips was, well, what's actually happening out there on the land transport network? I may not be on yours, but it certainly was on ours at the agency. There was a whole lot of work that went in around public transport, understanding what needs were during the different levels, what would that mean in terms of revenues, or what should we do in terms of the different types of services we should be providing. But what I wanted to focus on here is just one which also used the TomTom data that I talked about before. So one of the questions, and you know, there can be a lot of really good people who talk about, well, we think this might be happening, but do we actually know it's happening? So that was a really good question to ask, because our data scientists could actually go on this issue where the question was, we think people are speeding more during lockdown because the roads are quieter. So is that a myth or is it a truth? Good question. So we used the TomTom data to actually have a look at this, and we had a look at all the key roads across a number of different cities to actually understand what was actually happening, looking at the previous history across those roads, and then looking at the periods during lockdown as well. So what you can see on the graph here is that when you look at the very far right, which is the lockdown period, what you see is that in this particular route, Albany to Auckland, you had about 40% of the vehicles who were over the speed limits, compared to about 10% the same time last year. You can say, well, what benefit is that? In this way, we could actually work quite closely with the police as well, so they knew where the areas were where there were most likely to be issues or crashes during that period. It also meant that when we came out of lockdown, one of the worries, as you can imagine, is, are people going to continue to speed in the same way or not? I mean, obviously one question is, well, how many cars will be back on the roads? But through doing this type of analysis and this sort of work, working alongside the other government agencies as well, we're able to see where the hotspots might be in advance and be able to start watching them a lot closer and monitoring them to make sure that we can do all that we can to keep people safe during the post-COVID period. For you Aucklanders out there, I thought you might like to see something. So this is the impact of COVID lockdown on our road network across Auckland. Now, some of you might have a little bit of a laugh when you look at the dotted line there, the red one. That's actually if we're travelling average, just free flow traffic through Auckland. So I think one of the things that comes pretty obvious is that Auckland traffic hardly ever free flows. When you look at them, remember we're talking the major routes here, highways. What you can see though, what's really interesting is the difference between pretty much when you look at this year versus last year, the patterns all the way along were pretty much the same until you got to the lockdown period. And then you can see the dramatic effect that lockdown has actually had on the traffic movements and how the levels have actually impacted the traffic movements during this period. So this is just a higher level view of what I was showing you before, but I thought you might be interested just to see how the traffic was actually flowing during this time. Now, just to finish off, there's one last thing I thought I'd talk to you about. It's not one of our major work programs. It sort of sits across all, I guess you could say, in a way, which is we're doing more and more work in the unstructured data space, looking at natural language processing. Where we started to start with is in the market research area, where we've got a number of different surveys, one of them being our own survey, which is an internal employee survey, where we're looking at what are the themes that are happening in there and getting more sophisticated in the modelling work that we're actually doing behind that to get to the sentiment. Where we're heading next in relation to this is also then starting to look into other free text areas that we've got. So for instance, one is in our crash analysis database, where we have crash descriptions put in, where we can start to mine that to get a much better understanding at a much granular level, where otherwise it's just a whole lot of open comments that we're looking at. Where we'll be heading in the future with this is also into some of our other survey work and building up some really nice dictionaries that we can go back to and use, and then continue to build on those as we continue our survey work. So look, that's a really quick look at some of the work that we're doing at the agency. I hope that was of interest to you and look forward to telling you about more in the future at some point. Thank you.
Hello.
Hi, how's that?